A warship cuts through the waters of the Persian Gulf at more than 40 knots, a speed that defies logic for a mass of metal that size. On its deck, booster rockets ignite in a perfect sequence, illuminating the dimness of dawn. Small delta-wing aircraft pierce the sky, each carrying a warhead that costs less than a used car. One by one, dozens of them take off toward Iranian airspace. We are witnessing a historic milestone. The first time the United States Navy launches disposable attack drones from a warship in a real combat scenario. But the most surprising element is not the drone technology. It is the platform launching them. All of this takes place from the deck of a ship that the United States Congress itself attempted to cancel 3 times. The Littoral Combat Ship, better known as the LCS, is the program that defense analysts called for years an engineering disaster, a ship with hulls that cracked and gearboxes that literally self-destructed at sea. Today you will discover why the most criticized ship in history turned out to be the only correct answer for the hardest mission of the 21st century. Leave your like, subscribe, and share. Let's begin. Before understanding why they chose what many considered a broken ship, you need to understand the deadly trap that the Strait of Hormuz has become. Geographically, this passage measures just 21 nautical miles at its narrowest point, but the usable navigation lanes compress to only 4 nautical miles, 2 in each direction. Through this eye of a needle passes 20% of the world's crude oil every single day. Now look at what Iran has built around it over the past 4 decades. This is not a traditional defensive position. It is a kill zone engineered and specifically calibrated to destroy American warships. Beneath the surface, thousands of naval mines lurk, contact mines, bottom influence mines, and the fearsome M52 rocket-propelled mines that fire from the seabed directly at hulls. Behind those mines, more than 20 Ghadir-class submarines stalk the shallow waters with additional torpedoes. If you understand that modern warfare is geometry before firepower, this video is for you. On the surface, the threat multiplies with more than 1,500 fast attack boats of the Islamic Revolutionary Guard Corps. They are fiberglass hulls capable of reaching 50 knots, carrying Nasr-1 anti-ship missiles. They do not fight in formation, they swarm. They are a mass sufficient to overwhelm the computational capacity of any known defense system. From the air, drone swarms fill radar screens with hundreds of low-speed signals, bleeding the processing cycles of interceptor systems. And behind all that electronic noise, ballistic missiles descend at Mach 3, the real lethal payload hidden behind cheap decoys. The true genius of this Iranian architecture is how the threats are stacked in time and space. It is a mathematical problem. An Arleigh Burke-class destroyer carries 90 launch cells. If Iran launches 150 threats, the destroyer runs out of breath. This is where the geometry problem that seals the trap comes in. The Persian Gulf averages only 50 meters in depth. A Gerald R. Ford-class aircraft carrier has a draft of 11 meters, leaving only 39 meters beneath the hull. Influence mines detect the magnetic fields and water pressure of these giants. An aircraft carrier cannot maneuver evasively in a bathtub, where the enemy has had 40 years to equip every square mile. That is why the 100,000-ton supercarriers stay outside in deep water. But that distance creates an operational gap. The United States needed something that could enter the cage and solve 2 problems. An offensive one, launching cheap drones to saturate the Iranian radar network and open a path for Tomahawks, and a defensive one, clearing mines without risking sailors. Run the variables and you will see that only one ship fits the equation. Aircraft carriers are too large, destroyers and cruisers too valuable to risk in a short-range kill zone, and submarines cannot launch drone swarms from the surface. The Littoral Combat Ship, the LCS, despite its flaws, was the only puzzle piece that survived the equation. The ship the Navy wanted to throw away became the forward node near the Iranian coast. They needed a small radar footprint, a speed exceeding 40 knots to escape enemy targeting, and a deck large enough to operate drones in waters where large vessels would simply run aground or become easy targets. The LCS was designed in 2 variants, each with different illnesses. The Freedom class had critical problems in its combining gearbox, which ground itself into metallic powder. Ships like the USS Milwaukee lost propulsion on their maiden voyage. The Independence class, an aluminum trimaran, suffered from metal fatigue. Its skin tore apart under the stress of the waves. Congress held hearings and the media called it floating garbage. The critics were right about the defects. The gears failed and the aluminum cracked. However, they were wrong about what those defects meant on the current geopolitical board. By stripping the ship of its failed mission modules, something unexpected remained: a massive empty flight deck of 11,000 square feet. That empty deck, the result of a design failure, turned out to be exactly what the mission in Hormuz demanded. The trimaran geometry of the Independence class, with its 3 narrow hulls, provides a metacentric height that resists rolling. While a destroyer rolls violently in 3-meter swells, the LCS stays flat, with less than 3 degrees of roll. This stability is vital for launching drones with precision. The Navy stopped trying to make the LCS perfect and turned it into a modular node. They bolted drone launchers onto the deck without needing costly structural modifications. The failure of the original plug-and-play modules left the space free for the absolute flexibility that current drone warfare demands. Leave your like, subscribe, and share. The USS Santa Barbara was operating in the Arabian Gulf when the first low-cost, unmanned combat attack system, called Lucas, rose into the sky. It was the first time the Navy fired a single-use attack drone from a ship at sea. Lucas is an engineering paradox inspired by Iran's own Shahed 136, but improved with American precision. Engineers replaced the noisy engines with far quieter electronic injection systems. Most importantly, while the Iranian drone flies to fixed coordinates, Lucas maintains an uplink through Starlink, allowing a command center to redirect it against moving targets beyond the horizon. The true revolutionary capability of Lucas is its autonomous coordination. These drones carry swarm algorithms that allow them to communicate with each other. If enemy defenses shoot down one member of the formation, the algorithm automatically reassigns another drone to cover the target. This creates a computational crisis for Iran. Furthermore, the economics are devastating for the defender. Each Lucas costs $35,000, while the interceptor missile needed to stop it costs $5 million. The cost trap that Iran designed to bleed the United States dry now works in reverse. An LCS launches a salvo of 12 drones, and suddenly the Iranian air defense network must decide whether to spend a fortune or let the strike through. While the drones tore through air defense corridors, the USS Canberra and the USS Tulsa executed the defensive mission: mine clearance. The LCS mine countermeasures package operates under a simple principle. The ship stays out of danger and the robots go in. They use remotely controlled boats that tow high-definition sonars to map the seabed. If they detect a mine, they deploy unmanned underwater vehicles that swim toward it and destroy it. In the first 3 weeks of operation, they neutralized 117 mines in the Strait's navigation lanes. 0 American casualties, 0 sailors in the water. The LCS eliminated the human risk variable in the minefield, something the old minesweepers could not do. The results of these missions were written in fire on the surface of the Gulf. The Iris Jamaran, one of Iran's most capable frigates, was sunk. 3 additional warships were destroyed without even leaving their port at Bandar Abbas. Even Iran's cargo vessel converted into a drone carrier, the Shahed Vagari, was destroyed at its moorings. It is an irony of engineering. Iran spent years converting a commercial ship into an improvised drone carrier that never got to fight, while the United States took the ship that everyone wanted to discard and turned it into the drone carrier that changed the course of the conflict. The Iranian surface fleet, which was supposed to swarm and overwhelm American forces in shallow waters, ceased to exist as a coherent combat force. The LCS was never a good ship by traditional naval architecture standards. Its gears failed, its aluminum cracked, and its original modules were a financial disaster. But the equation of warfare in the Strait of Hormuz did not call for technical perfection. It called for the right answer to a specific problem. The LCS was small enough to enter the cage, fast enough to survive targeting, had a stable deck for launching swarms, and was cheap enough to be risked. In the world of military engineering, elegance is secondary to operational effectiveness. At the end of the day, the broken ships solved the geometry and economics dilemma that supercarriers could not touch. The defects that Congress criticized were, ironically, the very ones that left the space open for the innovation that saved the mission. This is the reality of modern naval power. Sometimes the system that looks like a failure on paper is the only one capable of winning when the mathematics of the kill zone become real. Engineering does not require perfect ships. It requires solutions that work when the first rocket ignites on deck. This lesson in defect reversal forces us to look beyond the headlines and understand the layers of strategy that define dominance of the seas. The next time you hear that a military program is a waste of money, remember the LCS in the Strait of Hormuz. What looks like floating garbage to a bureaucrat can be the ultimate weapon for an operator who understands the geometry of the battlefield. The United States did not choose the LCS because it was broken, but because what remained after its failures was precisely the tool needed to break the most dangerous trap in the world. Leave your like, subscribe and share. Until next time.